Hello everybody. So today we're going to look at problems involving equating of volumes. So this just means that we're basically getting one shape, calculating its volume, and then turning that volume into a different shape. Whether we're asked to do that literally or just in terms of our calculations, it works out that way. So there's three different ways that we can be asked to do this. The first one, and maybe the most basic one to get our heads around, is the idea of melting. So with melting, we could be given, say, a block. Here's our block there. Let's say it's a cube. So all the sides are the same. All the sides are 8 centimeters. Could be told that that's going to be melted down and turned into a sphere. And they want to know what the radius of that sphere is. So again, we're given a block. We're being told it's melted down and that it's going to be turned into a sphere of unknown radius. And they want to know how big that sphere will be and how big its radius will be. So you might have guessed from the title that the way we're going to do that is equate their volumes, right? So volume is our missing link that's going to let us solve that out. So if we were asked straight away to figure out what the radius there is, we wouldn't be able to do it straight away. Our instinct might tell us to write out the formula for the area, surface area, or the volume. So if we write out the formula for volume, it would be 4 over 3 pi or cubed. Now in this formula we actually don't know v yet, and we don't know or, so we can't solve it because there's two unknown variables there. So equating the volumes lets us figure out v first, and then we can fill it in to get the radius. So let's have a look at doing that now. Key here really is realizing that if we melt this down, the metal block, then its volume is going to be the same as when we turn it into a sphere. So the volume will be the same before and after. So let's figure out the volume first. So the volume of any cuboid is going to be the length times the width times the height. Because this is a cube, all those are going to be the same. So we'll just say it's the width cubed. So the volume here is 8 cubed, which works out as being 512 centimeters cubed. Now the equation of volume bit comes in when we make this volume equal to the new volume, right? Because it's the same amount of metal, so it'll have the same volume. Not necessarily the same surface area though. So we can fill in 512 for the volume. It's equal to 4 over 3 pi or cubed. Now we only have one unknown variable, so we can actually solve this out at this point. So if you're asked to give your answer as a decimal, you can do that. But let's try and get our answer here in terms of pi just to make it a little bit harder. So there's a few ways to solve this from here. To me, the one that seems to make the most sense, because we have only one term on each side, we want to get rid of that fraction on the bottom. Let's multiply each term by 3. So this will cancel out on the right hand side and we'll be left with 4 times pi times or cubed. On the left hand side, 3 times 512 will give us 1536. Now we're going to try and get or by itself. So that means we need to get rid of our 4 pi. So the way we'll do that is by dividing both sides by 4 pi. So on the right hand side this will cancel. When we're working out on the left hand side, actually I think we will probably have to get this as a decimal. Because we're dividing by pi, it doesn't work out as nicely. So 1536 divided by 4 pi gives us 122. And we'll just leave that to 2 decimal places. Again, on the right hand side, 4 pi or cubed divided by 4 pi cancels out to just give us or cubed. Now the last step we're going to take is trying to get ore by itself. We're going to get the cubed root of ore, and that means we have to get the cubed root of the other side as well. So the cubed root of ore cubed will cancel out and we'll just be left with ore, which is our plan. On the left hand side, the cubed root of 122.23 is 4.963 to 3 decimal places. Now you'd always check in the question how many decimal places they want your answer to. So let's say we're going to give it to 1 decimal place. Well, this will get bumped up then. So to 1 decimal place we'd have 4.9, but the 9 gets bumped up to a 10 because 6 is so big. So this actually simplifies down to being 5.0 if it's to 1 decimal place. Now we're looking for units, so we go back to the units that were given at the start, which was centimeters. Again, just looking at this decimal, the reason why that got bumped up to 5 was because 6, which is the last one we're getting rid of, is greater than 5. So normally the 9 would get bumped up, but you can't get bumped up any further than 9. So our next number gets bumped up instead, 4. So the second type of question they can ask us that makes us equate volumes is a displacement question. So what that looks like is normally there'll be some kind of a tank of water. So we'll draw one that looks like this. And that tank is filled up only part of the way with water. So say it might be filled up to here. Now they tell us that something is after being submerged in that water. So in our case here, let's say that there's a little block is after being submerged in there. To keep it simple, I'm just going to say that block is a cube again, because it'll keep this video a bit shorter. So the idea here is that when the block is submerged in the water is going to travel upwards because it's being pushed out of the way. So in a similar way that when you get into the bath, the water rises. When this block goes into the water will rise by a certain height here. Now the height that it rises by will depend on the volume, because the water is going to rise by a certain volume, which is going to be the volume of this cube. Now if you put in a bigger cube, the water will rise by more because more water is being pushed out of the way. So let's say that the radius of this cube, the radius of the cylinder is 1 meter. Let's say that the dimensions of the cube here is 50 centimeters. So 50 by 50 by 50. Remember, a cube is all 3 sides the same length. So the steps here are pretty similar. We're going to get the volume of the cube, and this will tell us what the displaced height is going to be. One problem that we can see here before we start is that they're giving us 2 different types of unit to plug into the question. So we have to decide on what unit we're going to stick with first of all. I think that I'm going to stick with meters, but I could equally stick with centimeters as long as I change the meters to centimeters. So if I change 50 centimeters to meters, it's going to be half a meter. And remembering that there's 100 centimeters in a meter, so 50 centimeters will be half that, or half a meter. Now if you want to find the volume of a cube, it's going to be the length by width by the height for any cuboid, or specifically for a cube is just going to be the width cubed. So we're saying that's half a meter cubed, which gives us 0.125, and because its volume is going to be meters cubed. Now, our next task is to figure out how much that height has risen by in the tank because this new volume has been added. So what's basically happening here is water is being pushed up It's creating like a new cylinder that just takes up this amount of space here. So we're just trying to find the volume of the new cylinder, and the volume of this cylindrical piece in red is going to be the same as the volume of the cube that was put in. So we're going to write out the volume formula for a cube. Volume is equal to pi r squared h. And for the red section, we know that the volume is going to be 0.125. We can say that pi is equal to 3.14 if we're going to get our answer as a decimal. The radius we know is 1, and h then is our unknown. So again, because there's only one unknown here, it's perfectly fine for us to solve this out. So let's start with our indices. 1 squared will just give us 1. 3.14 times 1 will just give us 3.14. To get h then by itself, we're going to divide that side by 3.14, which means we have to divide the left hand side by 3.14. They'll cancel on the right hand side, and we'll just be left with L, or H, sorry. My H's have just started to look like L's over the course of this video. And then the left hand side, 0.125 divided by 3.14, which will give us 0.0398. And because we've been using meters from the get-go, remember we changed our centimeters to meters, we'll use meters for our answers. So 0.398 meters. That's going to be how much this height has risen by. So sometimes people get confused with a question like this, thinking they need to figure out the initial height. They don't at all. You're just being asked to figure out the change in height, usually. So unless you're given the initial height to begin with. So the third and final type of problem that we can be asked about equating of volumes is flowing liquids questions. So they'll usually involve some kind of a pipe like this, and we're going to have something that the pipe might be flowing into. So in this example we might use a rectangular tank. So water's flowing out of that pipe and into the tank. Now, the important thing to remember is the amount of water that's flowing out here, or the volume that's flowing out of here per second, is going to be the volume that's going into here per second. So normally we'll be dealing with the volume per second here. So a classic example, they might give us the radius here of the pipe, and they might say that's 5 centimeters. They might say that it flows out of the pipe, that the pipe flows at a rate of 10 centimeters per second. So that doesn't mean the pipe is 10 centimeters long, but it means that in 1 second, if we were to take this section of the cylinder, whatever volume in here is the amount that would flow out of there per second. So you can imagine all of this water here leaving in a second, and then it being replaced with more water. That's essentially what's happening every second there. So in a question we might be asked, or might be given this information about the pipe, saying that it's got a 5 centimeter radius and it flows at a rate of 10 centimeters per second. In case you can't see that, it's cm/s, centimeters per second. They might then ask us how long would it take to fill up this rectangular tank. So we'll say that the rectangular tank is, or has dimensions of half a meter times 1 meter times half a meter. Okay, so equation or equating of volumes again just means that we'll figure out the volume here first, then apply that to the second part. So let's just figure out the volume of water that's coming out of that cylinder every second. So formula for the volume of a cylinder is pi r squared h. We don't know the volume, we do know that pi is equal to 3.14. We know the radius is 5, and we know the height is 10 centimeters. Bidmus tells us we should do our indices first, so that's going to be 5 squared is 25. And Bidmus tells us we should do our multiplication then next. So this gives us a total volume of 785 centimeters cubed. Now that's the amount of volume that flows out of that pipe per second. If we want to know how long it'll take to fill up this tank here, we've got to figure out what its total volume is. Now please don't make the mistake of mixing and matching your units. If we've used centimeters for the first part of the question, we have to use centimeters for the second part of the question. So our dimensions here are 0.5 meters. We could say that's 50 centimeters. 1 meter is 100 centimeters. And 0.5 meters again is 50 centimeters. So the total volume of that rectangular or the cuboid is going to be length by width times height. Again, we know how to do it, but it's really important that we write out the formula because that's what's going to get us marks. So then filling that in, that's 50 times 50 times 100. So that gives us the total volume of 250,000 centimeters cubed. Now we were asked how long it'll take to fill up that second container. So this is the total volume. This is how much volume is filled in per second. So we're going to divide the total volume by how much volume is going in per second. That will give us an answer of 318.47 seconds. Now again, we just check back to make sure that we've used the correct units, and if there is a certain amount of decimal places asked for in the question, that's the amount of decimal places we give. Again, it might not seem like a big deal, but it's just a good habit to be in because you will be given marks specifically for that in the exam.